Hello everyone! We are going to speak about the carbon nanoparticles. My name is Ronika and my colleagues are Olga, Laura and Mohammed. Nanocarbons particles are commonly used in water treatment and gas adsorption, and the new generation of nanoscale carbon structures are created. They have large surface area, novel electronic and chemical properties. Carbon nanoparticles group includes nanofibers, nanotubes, and nanodiamonds, and other nanostructures of carbon. And because of new research, new application horizons are going to be created.
So now we have synthesis of carbon nanoparticles. As we all know that intensive efforts have been made for the production of carbon nanoparticles, and these methods include pyrolysis, electrolysis of molten state, graphitization of particles obtained from microemulsion polymerization, and laser vaporization of carbon pellet. But here we are including the four main synthesis processes which are currently in use. The first one is the synthesis of carbon nanoparticles from waste rice husk. In this process, the carbonization of rice husk involves by using sulfuric acid, and high temperature needed for this process, and we get at 120 degrees Celsius temperature and 30 minutes of heating a black residue which needs further treatment by using centrifuge to get pure carbon nanoparticles. The second one is the carbon nanoparticle synthesis by ablation of carbon plate under the water surface. It includes the setup in which the carbon plate is targeted for producing carbon nanoparticles, and in this the carbon plate is immersed under deionized water with a depth of 5 mm below its surface, and the target plate is continuously rotated for the uniform dispersion of carbon nanoparticles. The third one is the synthesis of carbon nanoparticles by using supercritical carbon disulfide. In this synthesis process, the carbon disulfide reacts with lithium, in which the lithium converted into lithium sulfide, and for further reaction, lithium reacts with hydrochloric acid to form lithium chloride, which is easily soluble in water, and we will get the carbon nanoparticles in very pure form. And the fourth one is the green synthesis of carbon nanoparticles from honey, in which food grade honey is in use, and it is suspended with organic macromolecular or molecular passivating agent which purged with argon and heated in domestic oven to get carbon nanoparticle. But this process also need the further treatment of centrifugation to get pure carbon nanoparticles.
So these nanoparticles are amorphous and semi-crystalline atomic structure. Here we have in the figure 1 and 2 a graphical representation of those particles. The characteristic dimension is in between 1 and 100 nanometers. The structure is similar to fullerenes, but they are higher in size. They can have several layers and have a closed structure. The atoms inside the nanoparticles are connected between them by chemical bonds, and between atoms on neighbor shells they can be connected with weak van der Waals interaction. Normally the nanoparticles have the shape of a shell with pentagons and heptagons. So the adsorption mechanism is made in two stages. In the first stage, we have is represented in the figure A and B. We have the formation of water clusters that are called primary adsorption sites. These have slow dynamics because depend on the pore size. After we have the second stage, is represented by the figure C and D. Here we have a cooperative adsorption where the initial primary adsorption sites merge, filling all the pores. This step is characterized by a steep increase in water absorption. In the figure 4, we have the absorption isotherm example. Those isotherms are normally as a S-shaped form. In the relative pressure, low relative pressure, we have low water absorption, and then it will increase rapidly at medium relative pressure, and when it's approaching the saturated vapor pressure, we will have an absorption plateau. Well, speaking about the chemical activity of the surface, we will have they are mainly described by the morphology of the particles. We can have a Gaussian curvature that if you see the figure 5, you can have a negative curvature and a positive curvature. And they are also described by the carbon hybridization that is well known about the orbital sp, s, or sp3. When we have flat system, that means that they have zero Gaussian curvature, they do not interact strongly with other chemicals. So that leads us in a need of some modification to enhance that interaction. Where there are 3 modifications possible. The first is doping, that it means that we will tune the electronic and chemical properties, introducing atoms as nitrogen, boron, phosphorus, sulfur, or silicon. The second one is defect creation, that will enhance the surface area by the creation of vacancies, bond rotation, introduction of non-hexagonal carbon rings. And the last one is chemical functionalization, that is the introduction of the small functional group, such as carboxylic and amine groups, or large molecules such as polymers and biomolecules, to enhance the chemical bonding of the particles.
Carbon is a great element for delivering medicine and other substances to human body, especially at the cellular level. Because of this, carbon nanoparticles can be used for the delivery of drugs at the cellular level. Carbon nanoparticles also can be used in medicine. One of the examples of field is cancer treatment. Another diseases which can be treated by nanoparticles are Parkinson's disease, chronic pain, and depression, but they are still under research. Carbon nanoparticles are also used for development of high-capacity lithium-sulfur batteries. And the last but not the least, they're also used for water treatment. They work as adsorbents, and the carbon nanoparticle can remove the pollutant or separate it from treated water. It removes heavy metals, sediments, chemical effluents, charged particles, bacteria, and other pollutants. The main process for effective destruction of persistent contaminants is the catalyzation of chemical or photochemical oxidation process. For efficient removal of metal ions such as zinc or nickel and radionuclides, synthesized carbon nanoparticles can be applied to the water. And the ion exchange capacity is relatively high, it's 7.4 millimole per gram, and it happens due to the functional carboxyl groups. Here you can see references which we used for making this presentation, and if you'd like to learn more about the carbon nanoparticles, feel free to use these links. Thank you for your attention, and see you in the lessons.